Hi, and welcome to lesson 5.7, using congruent triangles. Now, we're going to be using all of the tools that we have been using throughout the whole chapter and applying it in a slightly different way. What we're going to be doing is we're going to be doing what we call an indirect proving. Okay, well, not indirect proving, but using indirect measurements to prove something. So here's your scenario. And by the way, we're on page 153. Now this surveyor is trying to measure how wide the river is. Now back then there was no GPS and there's no fancy ways of measuring across a river. Besides, now we have GPS and various different ways. So they had to come up with different ways of doing this, and what they use is indirect measurements. Now, what the surveyor does is that the surveyor is going to but they're going to try to guess what is the distance between A and B, which is the width of the river. So what the surveyor does is the surveyor walks a set distance all the way up to C. He puts a mark right there, and then walks the same distance over to here, making this distance and this distance the same. What the surveyor does now is the surveyor walks inland at a 90-degree angle until the point where he put the stake at matches to this point and the point across the river. Now, if the surveyor can figure out what the distance from D to E is, then he can figure out the width of the river. Why? Because when you do this, you're creating two sets of right triangles. And that is what we're going to try to prove. Why is it that these two triangles are right triangles? Okay, so here's what you have. You have here that angle A is a right angle, and so is angle D. Okay, just by the scenario of how it was created. Okay, and they also tell you that AC is congruent to CD. And what we're trying to prove is that AB and DE are going to be congruent. Okay, so here's what we're going to be using. Okay, we're going to be using the fact that these two angles right here created by this scenario are going to be vertical angles. So therefore, this angle here and this angle here are going to be vertical angles and therefore congruent. Now you have angle, side angle, meaning now that the triangles are congruent, and because the triangles are congruent now, DE will be congruent to AB, which is what we are trying to prove. So let's begin. Okay, our first step is to list what is given to us. Angle A and angle D is a right triangle. Right angle. You should say are right angles. I may teach math, but I'm trying to get some good grammar in here. Angle A and angle D are right angles. That's given. Okay, by the way, you can cross off the little piece right here. Okay, the second thing they tell us is that AC is congruent to CD. That is also given, and that's going to be one of the sides we're going to need. All right, so here's the thing. Looking at this, angle A and D, they're both right angles, so therefore they must be congruent. Angle A congruent to angle D. Why? Because all right angles are congruent. And I'm pretty sure it's like the right angle theorem or something like that. I can't remember the name of it. Doesn't matter, as long as I can justify it. And that's my other angle. So now let's look at the fact that you have this angle and this angle. They're congruent because they're vertical. So angle BCA congruent to angle ECD. Why? Because they are vertical angles. So now we have a pair of angles, two pairs of angles, and an included side, which means now that the triangles are congruent. So triangle ABC is going to be congruent to triangles at ABC, DEC. Okay, and what's the reason? Angle, side angle, congruence theorem. Okay, so now that we have established that the triangles are congruent, their corresponding parts are going to be equal or congruent. Okay, so AB is going to be congruent to DE. So AB congruent to DE. Okay, and what's the reason? I don't know if you guys remember this from last time. Corresponding parts of congruent triangles are congruent. It's what we use after we prove triangle congruency. That's going to be one of the things that people are going to have a very difficult time remembering. CPCTC does not prove triangle congruency. It's what you use after you prove that triangles are congruent to state that a pair of corresponding either angles or sides are congruent. Let's look at page 154 now. So here is an alternative method. Now, by the way, get a quarter of a sheet of paper and just glue it on top, or simply cross off what's under there and leave yourself enough space, because we're going to do a second proof here. Okay, so what you have here, and I know it's a little hard to see in the diagram, but this person is standing at the edge of the bank. Okay, they're looking at a point all the way across on the river. Now, the person is going to then turn to along the edge of the bank and identify a point that will be pretty much the same distance. Okay, now here's how it will look like if I were to split it and see it a little different, like this. Okay, so in theory, this person is going to have the same height. Okay, the person is going to stand at a perpendicular angle, and the angle of elevation is going to be the same, meaning this angle and this angle are going to be the same. Therefore, the two triangles would be congruent by angle side angle, implying that this side right here, but that's DG, that EG and EF are going to be congruent, which is what we are trying to prove here. So let's go ahead and start our indirect measurement proof. So step one, they tell you that angle DG and angle DEF are right angles. That's given. Also, they tell you that EDG is congruent to EDF. Okay, that's also given. So here's the thing, because those are right angles, they're also congruent. So angle DEG congruent to angle DEF. Why? All right angles are congruent. So there you go. You have an angle, and guess what? Now you need an included side, which is that segment DE, because the person's not going to change size. So DE is congruent to DE. That is called the reflexive property of congruence. That's your other side. So now you have two pairs of congruent angles and an included side. So angle, side, angle, triangles are congruent. So triangle FED congruent to triangle GEF. ED. And what's the reason? Angle side angle congruence theorem. Therefore, EF and EG are congruent by CPCTC. And there you go. All right, so let's go ahead and start with our two examples. And they're going to go on page 155. Problem 1 here, problem 3 right there. Okay, so they've got quite a lot of space. But before, let's make sure that we cross off the problems that we're not going to do in the extra practice. So on page 156, cross off number 2. And on page 157, cross off number 6. You do not need to do that. So let's begin our examples. Okay, so for this example number 1, okay, I know the diagram can possibly be a little confusing, but what you have here is this glider. You have angle 1 and angle 2. They tell you here that they're both congruent, and they tell you that RTQ and RTS are congruent as well. And we have to prove that QT and ST are going to be congruent. So it might help if you look at the diagram without all the other information. So let me just redraw the diagram, make it look a little bit better. Okay, so here's what you have. You have 1 and 2 that are congruent, okay? And they tell you here, here's Q, R, T, and S. Okay, so they tell you that RTQ, this angle, is congruent to RTS, which is this angle here. Now, they also tell you that this angle here is congruent to this angle right there. Okay. Now, here's one thing we're going to need. We're going to need the reflexive property of congruence for RT. And here's the thing that you may or may not understand, okay? This angle here is supplementary to this one. This angle here is supplementary to this one. So both of these are the same angle measurements. So these two angles are supplementary to the same angle, making this angle and this angle congruent by the congruent supplement theorem. And that's the part that might be a little confusing. So if I can show that this angle here is congruent to this angle here, then the two triangles are going to be congruent by angle, angle, side, making QT and ST congruent by CPCTC. So let's start the proof now. All right, angle 1 congruent to angle 2. Angle RTQ congruent to angle RTS. Let me give myself a little more space here. And that's given. Okay, so here's the next part. Okay, let's look at the angles here first. So angle RQT is supplementary to angle 1. For the same reason, angle RST is supplementary to angle 2. And this is just the definition of a linear pair. Because, I mean, they are linear pairs, right? So because 1 and 2 are congruent, that would mean that these two angles are congruent. So angle RQT is congruent to angle RST by the congruent supplement theorem. Okay, and that's going to be one of my angles. And this one right here, the one that you see right there, that's going to be my other angle. And now I need a side. My side is going to be RT. So RT congruent to RT. Reflexive property of congruence. So that's my other side. So by angle, angle, side, the two triangles are going to be congruent. So triangle QRT is going to be congruent to triangle SRT. Why? By the angle, angle, side congruence theorem. And therefore, QT and ST are going to be congruent. Why? CPCTC. And therefore, you have now proven that QT is congruent to ST. And that was example number 1. Let's take a look at the last example. Now for this last example, we're going to have to split this diagram into two pieces, and you'll see why. What you have here is that angle 1 and 2 are congruent and 3 and 4 are congruent. And what we are trying to prove is that triangle BCE and triangle DCE are congruent. But if you just look at those two, if you just look at that small piece right there, C, D, and B, the only thing that you have is that these two angles are congruent. And maybe that this side is congruent to itself, but that's all you know. That is not enough to prove that this triangle and this triangle are congruent. Okay? So what I need to do is I need to show that CD and BC, CB and CD are congruent. So that's what I need to show. So I need to prove first that BC is congruent to DC. I need to do that first in order to show that these two triangles are congruent. So what I'm going to do is I'm going to look at the larger triangle, the one that's above and below. I'm going to look at this triangle right here and this triangle right there. Okay? So C, D, A, and C, B, A. Okay? Now I do know that angle 1 and angle 2 are congruent. I do know that angle 4 and angle 3 are congruent. That's given to me. Now here's the thing. AC and AC, they're exactly the same thing, so they're congruent. Now this is going to demonstrate that the two triangles are congruent by angle side angle, which then will imply that BC and CD are congruent, which is what we're trying to do. And therefore the two triangles are going to be congruent. So that's my plan. This is all part of the plan. Now I just got to execute the plan. So let's execute the plan. Easier said than done, huh? Okay, so they tell you angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. That is given. Okay, so 1 and 2, 3 and 4. It always helps if you split it up. So if you look at this part right here, you know that AC, AC is congruent to AC. Why? Because of the reflexive property of congruence. Therefore, you now have angle side angle, angle side angle. So triangle ABC congruent to triangle ADC. Why? Angle side angle congruence theorem. Now that is going to imply now that BC is congruent to DC. Why? corresponding parts of congruent triangles are congruent. Okay, so now that these are congruent, I am going to look at this side right here and this side right here as congruent. Okay, but I need to talk about this part right here. Okay, so I have CE congruent to CE. Why? Again, by the reflexive property of congruence. I already had angle 1 and 2 congruent. Okay, and now because I just proved this, okay, I can now state that the triangles are congruent. So triangle BCE is congruent to triangle DCE. Why? Because of side angle side, side angle side. This was a bit of a complicated proof. Okay, I might need to go over this in class again. Okay, please make sure you work on your extra practice, and I will see you later.